Okay, in your week 7 modules, there's a PowerPoint presentation for starting with chapter 4, section 4.1. And I'm just going to go through that to introduce the concept of polynomials. And so I'm going to share my screen. Let's see. Okay, so here we have 4.1, more nonlinear functions and their graphs. And we're going to learn terminology about polynomial functions, and we're going to find extrema of a function. Extrema is just a fancy word for extreme value or extreme values, and those would be like maximums of your function or minimums of your function. We're also going to talk about symmetry around the y-axis, and that would mean that you have an even function. And then we're also going to talk about odd functions which have symmetry around the origin, and I'll show you what that is. Okay, so a polynomial function f of degree n in the variable x can be represented by this funny looking function here. Don't be bothered by this strange way of writing this function. N is an index, so it's just telling you how high you're going to go as far as your degree. So the degree is your n. So let's suppose you have a degree 5 polynomial. Then you would have your first term being x to the 5th power, and then you would have some constant in front, like a 2 or a 3 or square root of 2, whatever your constant is. So this a sub n is the constant in front of x to the 5th, let's say, for example. Then the next term down below that would be your x to the 4th term, where you have 5 minus 1, so that would be 4, and this just represents the coefficient in front of that. So it's kind of a strange way of writing it, but think of a linear function and quadratic functions are both polynomials. They're a certain type of polynomial. So a linear function would have degree 1, and a quadratic function would have degree 2. So now what we're doing in chapter 4 is looking at higher degree polynomials, such as, like, say, f of x equals x cubed, or f of x equals 2x to the 5th power minus 4x to the 4th power plus 1, or something like that. So these coefficients, just like with quadratic functions, could equal 0. So the coefficient is a real number, not equal to 0. That's the leading coefficient. And so if it's not equal to 0, then you're going to have the degrees. I'm sorry, a sub n is not equal to 0. And that's the degree of the polynomial. A sub k could equal 0. That would be the other leading coefficients in front of your terms, your x terms. So I know this is a lot of jargon, but once we start doing examples, you'll feel more comfortable with it. And that's the next slide. We have some examples here. So here we have a polynomial, which is actually a constant function, and it has degree 0 because it has no x. And x to the 0 power is 1. So your constant, your very last constant is 10, and that would be times x to the power of 0, but that's just 1, so you just get 10. In the next example, this is of degree 1. So you have a linear function that's not constant, and here's the leading term. The power on x is 1, so this polynomial has degree 1. And the leading coefficient is this 2, which is multiplied by your x. So this is your leading term. In the next example, we have a quadratic function. Now, it's not written in the right order. Typically, we start with our x squared term because that's the leading term with the leading coefficient here of 3. So the highest power on x in this function is 2, and that's why it's a degree 2 polynomial. And quadratic functions are degree 2 polynomials. So this leading coefficient is 3. Even though it's not listed here in the front, it is still the leading coefficient because it's multiplied by x squared, which is the highest power on x. So in the next example, we do have it written in proper order because we have the highest power on x is 6. Then we're missing the x to the 5th term because the leading coefficient on the x to the 5th term is, I shouldn't say leading coefficient, I should say the coefficient on the x to the 5th term is 0, so it's gone. And same here for the x cubed and the x squared terms, the coefficient on those terms are 0. So the only terms we have here are x to the power of 6, x to the power of 4, and x to the power of 1, and the highest is 6, so the degree is 6, and the leading coefficient is the 1 in front of the highest degree term, which is this one, and so it's -1/2. So that's some terminology. Here's some examples. This is a parabola, and it has a quadratic, it's a quadratic function, so it's a parabola, and it has a vertex. Notice since it opens up, this vertex is the location of an extreme value, and that would be a minimum value of -6. -6 is the lowest point. And the 2 just shows us where that occurs. So it occurs at x equals 2, and the lowest value is -6. Here we have some more extreme, we have 2 local maximums. And we say local because, well, in this particular example, this one is the absolute maximum. It is the absolute highest point, and the absolute minimum is none here. And this is actually not correct. I did not, comes from your textbook. And I guess, oh, they're looking at this one here. I'm sorry, I didn't see that. That is correct. So A and B. So now here at C, this is an absolute maximum. So the value is 12.7, and it occurs at -2. You always look at the y value for the extreme value. This is called a local maximum, and the value is 2.25. And the reason why it's local is because near the function around it, it's the highest point. It's not the absolute highest like this one over here, but it is locally, it's the highest point. So we call that a local maximum. And then here is a local minimum of -3.1. There is no absolute minimum. You can see here it says none, and that's because it goes down infinitely. Okay, so originally I thought these were incorrect just because I was looking at these values for this graph, and you can see they're labeled here, so I hope you caught that. Anyway, that's an introduction. I'm gonna do some more videos talking about this in more detail.